All right, does it work? Power. That can help. 111. Ah, it does work. Does it? Does it? All right, good. Good evening, everybody. Thank you for coming. Please join us here. And on your way, the beers, the most important part of this evening, the beers are over there in the back. Yes.
Can everybody take a seat? We're about to start. Can everybody take a seat? We're about to kick this off. Get the show on the road. Great. Can the folks hear me in the back?
I think so. I'll and it's not reversed. It's not mirror. Wrong. Good test?
Hello. Can you hear me?
We can. Sure.
Close the food. No, just kidding.
Yeah, just kidding.
We're just kidding. No, we're just kidding.
Can everybody hear me? No. Sorry. Hear me now? All right. I can also talk really, really loud. All right. Hi, everybody. Thank you so much for coming out to the world's largest Kubernetes meetup. My name is Paris. This is Dewal. We are organizers tonight. Very, very quick intro that I wanted to kick things off with. First and foremost, thank you so much to JFrog providing us with a space. Carolyn is waving. Baruch is waving. He's going to come up here in a second and talk to you about JFrog's contributions to Kubernetes. Yeah, the space is awesome. Again, Chipotle is great. No pizza, yay. So I work on contributor experience. I actually co-lead the special interest group. So if anybody here tonight is interested in upstream contributions, that's my wheelhouse. Yeah, exactly. And let's kick things off. All right, thank you.
Thank you, Paris. Just a couple of minutes about who we are and what we are doing and why we are so excited to host the Helm meetup here. So first of all, this happens every month, different topics, not necessarily Kubernetes or usually DevOps related stuff. Good food, good beer, good talks. Subscribe to our meetup group, please. That's one. Now, does this? Oh, there you go. It works. So more familiar with JFrog? Yeah, here you go. Right, JFrog, we deal with binary files, with your artifacts, and we take care of your artifacts basically for everything between Git and Kubernetes. We have universal artifact repository that can host your Helm charts, the Docker images that are described in those Helm charts, and everything that it goes into those Docker images. And you can establish metadata, cross-cut through all those, which basically gives you visibility over this process. It's a distribution platform that allows you to publicly distribute your software in whatever form you distribute it. We are a proud member of the Cloud Native Foundation. We're contributing to Helm, trying to make it a better dependency manager, because dependency managers suck. But Helm will be the one which won't suck, and it will be awesome. Artifactory itself supports Helm as a Helm registry since Artifactory 5.8, which was released a couple of weeks ago. So those are big news for us. And with all those news, we, and hopefully you, are going to meet again at the Helm Summit, which will take place very soon, actually a month from now, less than a month from now, in Portland. So if you are going to be here, to be there, don't forget to stop by, say hello. We have a talk there, and we will be there, and we will be very happy to meet again. Couple of more things. First of all, we are hiring, so if you have friends that want to work in this amazing environment, send them to join.jfrog.com. We basically hire like everything. Me personally, I'm excited about. Does it work? Yes, almost. Does it work? Yes, the top row, which is developer advocates, and I need help. So yeah, if you know awesome developer advocates or awesome developers who want to become developer advocates, send them to me. If you know other amazing people, send them to join.jfrog.com. Last but not least, who recognizes the place? Napa, California. Who heard about Swamp Up? The amazing JFrog user conference in Napa, California? Couple of people. Now you all. And we have like an amazing pricing going on, which is called the Blind Bird, because the agenda is still in the making. So if you want to speak at Napa, California, and this is how you get for free to this amazing event, talks about Kubernetes, Helm, containers, DevOps, everything, go to the website and submit a CFP. If you trust your colleagues to submit awesome talks, you can go ahead and buy. We did announce the training day and its agenda, and the blind pricing is going to end in 3 days. So today, or, tomorrow will be a good opportunity to book your seat. With that, thank you very much. Let's start with the real part of the evening. And first speaker, here we go. No, that wasn't the real part. You should welcome Andrew with your round of applause.
Nice.
Here you go.
All right, good evening. I was told that this would be a full house today, and it's certainly nice and flattering to see so many faces have my attention. So thank you all for coming. My name is Andrew, and I'm from Mirantis. I'm a technical instructor. I teach about OpenStack, Kubernetes, MCP, which is our product. And today I'm here to talk to you about orchestration for Kubernetes. I think the developers of Kubernetes wanted to make one thing clear. They say that You look in their docs. We're not a mere orchestration system. We're not just some mere little thing. So what is orchestration? How would you guys define orchestration? Shout it out to me.
Monitoring automation.
Okay. Monitoring automation. Okay. What else?
Arranging the order in which things happen.
Arranging the order in which things happen. So you're defining a particular ABC to make it happen. Monitoring and scaling containers. Okay.
No DevOps, only developers.
In any case, in a broad sense. So that's what we would think orchestration is. So it's an automated arrangement, coordination, and management of computer systems. And so if this, then do that, right? So that's orchestration. And Kubernetes did not want to be associated with that. So I think the best person who's described Kubernetes was Joe Beda from Untitled. He says, Kubernetes is like a jazz improvisation. So if orchestration means there's a central conductor with some defined nodes and they have to play exactly what's defined, then Kubernetes is more like a jazz improv, right? You know what your desired state is. You know what the desired sound should be. We're going to play off each other to make that desired state happen. And that's what Kubernetes is doing. So thank you, Joe, for that wonderful definition. So if we look at its components, we have some usual suspects. We have the master and the node itself, which used to be called a minion. Now it's a node. The master, we have the API, etcd, controller manager, several other components. And the node itself will run your workload, right? So if you're talking architecture diagrams, it looks something like that. And the industry has come up with various solutions to help you deploy your cluster as well as your application on Kubernetes. So it's various different levels that we're going to be talking about today. And our goal is to figure out where your particular needs lie. Okay, so the hosted, turnkey, private, and custom. And to keep all of this in line, you've not heard of Cloud Native Computing Foundation. They're the big daddy, the overseer of Kubernetes, and they want to make sure that everyone works together in a way that makes this project shine. So this conformance program, if you are a provider or service provider of Kubernetes, and you want to be certified by CNCF, make sure that those members guarantee complete API functionality and commitment to provide latest versions to the end users. So that's what that is. Let's talk about cluster management. How do you manage your cluster? Does anyone have Kubernetes running in production? What does it look like? It's a big secret.
Not in production.
Not in production, okay.
Well, we use Kops.
Okay.
We use Kops to create and manage it.
So we have one individual who's familiar with cluster management. So just big ideas to consider. Who's going to provide your cloud? Who's going to provide your infrastructure? What's your network going to look like? And what are the binaries and things you're going to run on Kubernetes? And if you think you don't need orchestration, you're just going to do it the hard way. This is called the Kelsey Hightower Kubernetes the Hard Way. And Kelsey Hightower is a respected Googler whom I really like. And he devised this practice method to deploy Kubernetes. And it's purely for learning experience. But what you do, you go to Google Cloud Platform, you have nothing, you make your account, you initialize your cloud, and set up your network, make sure your subnet is in line, make some firewall rules, and then you have to create your instance. So these are virtual machines so that you can host Kubernetes. So you do some instance create, you log into those nodes, you give it configurations of Kubernetes, then you have to log in there and set it up and run the services, and then finally set up your kubectl, and then you have access to your cluster. So you could do that, but as we go along, we'll discover some tools that'll help you to deploy Kubernetes. So any of these look familiar? Who's used kubeadmin? I'm guessing that's how you pronounce that. Yeah? Okay. And how does that work for you?
Works pretty well. It's not
Okay. So according to them, they describe it as a minimally viable cluster, which passes the conformance program that we talked about earlier. We have more advanced tools like Kops. So Kops is your production grade cluster management tool. You have Juju bundles, Cube Spray, which is based on Ansible. So you have these different options, which all have these slight differences in the tooling and the backend that they use to help you deploy Kubernetes. So if we take a look at a closer look at Kops, and let's say we're using Amazon as our cloud provider, you first have to go to Amazon, configure your users to make sure that Kops has access, and your DNS, then your S3 for cluster information. And then you simply go to Kops and say, give me a cluster. And Kops will do the magic of talking to Amazon and spawning your auto-scaling group, which will become your Kubernetes cluster. Now, a level on top of that would be Kubernetes that's hosted, right? Someone's doing the job of all of this for you, and in the end, you just receive a cluster. So the top 3 dogs provide these solutions. And Google obviously has gotten there first, and their product is, you could say it's the most mature. And this is your fully managed instance on top of GCE. And they have their own Kubernetes optimized operating system, and they utilize the upstream Kubernetes. And Amazon and Azure are sort of playing catch up. They have this preview stage. And if you wanted to go use EKS, for example, you have to actually provide some information and say, hey, I want to test this out. And then you might get access to their EKS platform. But they say that it'll be available sometime in 2018. So we'll give Azure some spotlight here. As a developer or a production operations person, create your application images and then deposit them into the Azure container registry. And then you say, Azure, create me my cluster. And Azure will do the job of creating all the instances underneath and then deploying Kubernetes and giving you a fully operational cluster. Now, if you have a more complex case, you are an enterprise or big company like AT&T, and you have thousands of clusters that or nodes that you want to deploy to, you might turn to a multi-cloud turnkey solution. And this is where Mirantis is. This is where CoreOS and Red Hat and Joyent are operating. And essentially, they have their own tooling as well as services bundle that help you deploy your Kubernetes. And usually it also comes with another cloud platform that you might use in conjunction with Kubernetes as well. Okay, and some of you might say, I just want a container, give it to me now, right? So those are sort of serverless on-demand containers. And you might see players like AWS come up with things like Fargate, which has been most recently announced. That one, you go ask AWS for a container, and then you receive it, just the container and no cluster. They'll manage the entire cluster for you. And so some use cases for this is not going to be a big production level application. This is more oriented towards your task level apps as well as some build jobs that you might have. But neither of them are based on Kubernetes. If you ask for a container, they might give it to you on ECS. And they say that they're going to support Kubernetes sometime this year. So that's something else to look for in terms of orchestrating Kubernetes. So here's our anxious user. Give me a container now. Here's my image, the resource I want, and the networking setup. And then Fargate will give you a container just as you would ask EC2 for an instance. Has anyone tried this out before? Here it is. Okay, so that's your cluster. So those are your different levels. And at the end of the day, you do want orchestration if you're serious about deploying a cluster of Kubernetes for your application. Now, on top of that, you finally managed to have a cluster, and it's highly available, it's production ready, and it's time to think about application management. And if you think you need orchestration for that, what is a tool that does that? Helm, okay. Spinnaker, yeah, good. So Kubernetes itself, right? I mean, it's the king of managing your application. So do we really need something on top of Kubernetes to manage my application? So first we'll talk about the Kubernetes Way. And hopefully we're all familiar with how that works. You currently have a cluster and your containerized application. And then you do a basic deployment, right? You create your deployment.yaml file. You specify the number of replicas you'd like, and then you deploy it, and you expose your application via the service. And that's how you manage that workflow. And Kubernetes continues to improve on the way that, or the feature sets that you have. So recently they announced version 1.9. And so this is a more mature version where it provides you a bundled application level sets. So you have your replica set, daemon, deployment, and stateful. And those are now available out of beta. And so you would use the tag apps/version1. And they provide things like container storage interface. They realize that persistent storage is important in Kubernetes. So rather than a backend provider having to go to Kubernetes code and have a compiled version to have their product available, they're going to provide us an interface, and then they just have to develop a storage solution that plugs in to the Kubernetes interface. If you're big on Windows containers, that support continues to grow. And of course, it's trying to support multiple cloud providers. And I think that's what's great about being open source and really encouraging these cloud providers to adopt Kubernetes. So if you got to this point, congratulations, you have your cluster, you have your application ready to run. And hopefully it's following the 12-factor application level. So can someone tell me what code base might refer to in a 12-factor app? It's the code base? Okay, so it's the idea that you should have one code base, not multiple enumerations and different, located at different places. You should have one code base. Your dependencies should be obviously stated, clearly stated, and not some implied thing. So you can definitely save this in your notes and then look up all of the different ways to make your application ready for Kubernetes, to make it more microservice friendly. So that's the idea behind the 12-factor app. And so that's one of the complete ways wherein your application level stack is ready for Kubernetes and orchestration. So now why do we need orchestration on top of that to manage my application? Because multi-cloud matters. Because there's no really easy way to manage my applications across multiple clouds of Kubernetes clusters. So if we look at some of the reports and surveys, over 85% of the industry is saying we're using multi-cloud. We want to use multi-cloud strategies. So that means either combined with my private cloud running in my own cluster, or AWS, Azure, and Google. I don't want to be stuck with one provider. I want to be able to scale out more. Those are all strategies that pertain to multi-cloud. So one way to do this, Kubernetes actually has a solution that addresses this need. And one way to do this is called Kubernetes Federation. The Federation, you choose one of your clusters. So you already have multiple Kubernetes clusters. You might have one on GCP, you might have one on AWS. And then you choose one of those clusters and you make it a control plane. It's a master control plane. And now instead of talking to individual clusters, you can talk to that one control plane. And then it'll pass down the message along to the rest of the cluster. So that's the idea behind Federation. And key reasons are higher availability. Right? You can deploy clusters across more regions, more clouds, and application portability. So making sure that your app is not stuck on a single provider because you're used to their features and you have no easy way to migrate to a different cloud. And it's still in the early stages of development, but it is being used plentifully. So when you go do your deployment, rather than talking to an individual cluster, talk to the Federation API. That'll handle passing down your commands and workflow down to the various cloud providers where you have set up your cluster. Spinnaker. So it's your open source, multi-cloud, continuous delivery platform. And there's two big ideas of Spinnaker, two big, points in Spinnaker: server groups, where it's your artifacts, your containers, and VM images. So it's sort of a level beyond Kubernetes. It can be VMs, it supports OpenStack as well, and your configuration settings. And then you have your pipeline, which will manage your deployment scenarios. So the way Spinnaker works, it achieves this abstraction with a bunch of microservices, and those services will handle talking to the cloud providers that you saw underneath here. Okay, so the landscape for Kubernetes continues to grow and it's fast. And if you go to CNCF, you can see the different types of programs available under this project. So where does that leave us today and beyond? So what the future holds. And I think this is best described by this text conversation image that's been sent over to me from my girlfriend. This is a conversation between her mother and her dad. So she asks Danny, that's their dad, "Hey, are you home?" Being a good husband that he is, he says, "Yes." Then she asks, "Do you remember where you hid Jordan's weed?" And mind you, their family is not, they're nice folks. They don't really do drugs. And so he's rightfully surprised. What are you talking about? "Oh, I meant Jordan's weed. LOL, stupid Siri." So what are we talking about here? Communication, okay. So I'm talking about machine learning, right? Deep neural network of Siri. So clearly, Siri has identified or correlated that, hiding has a high correlation with weed. Machine learning is the algorithms that are trying to make machines smarter or more humorous. I think either way works. So you're feeding it a lot of data so that you let it learn and conduct actions by itself. So this is all for the sake of making the end users happy. And how can we apply this to our infrastructure? And I've had a few ideas. So in a typical environment, we have our pipeline where we can contribute our source code as well as our infrastructure configuration. And then that makes its way through the QA environment as well as production, which ultimately serves the end user. So how do we make the end users happy today? How do we make sure that the services are up and running all the time? How do we make sure that they're not experiencing big latency? Any ideas? Any tools that we use today to make sure that the end users are satisfied? Sorry? Okay.
APMs.
APMs, yeah. Monitoring, right? Logging. So we have these critical data that we're logging and monitoring excessively, but we lag behind on sort of the implementation aspect of it. How do we pinpoint what the user is experiencing? One way that we can leverage machine learning is to take the data and feed it to machine learning and give it access to our pipeline to deploy our application, to deploy our infrastructure across our clouds. So we take that data, put it through some testing, and then give it to the production. Now, if this works out, then the end user is the sole contributor to our production environment. So as an example, we have a developer with the code, and we have a lot of tools today that helps us deploy to multiple clouds. That helps us be efficient about the way we deploy to those clouds. But it's not always concrete. Why we're deploying X number of instances across Y number of clouds and giving it certain memory and CPU. So rather than doing that sort of guesswork, we're going to allow the end user or monitor the usage of end users and then retrieve that data and feed it through our machine learning algorithm that will help us deploy our application in a more efficient way across multiple clouds. So ultimately, I think that infrastructure service will continue to grow and evolve abstractions and orchestration methods so that its control is at the fingertips of the end users. So at the end of the day, we want to serve our users a good, nice cake with our orchestration layers. All right. So to top it off, I wanted to give a little plug to Mirantis training. If you go to training.mirantis.com, you can utilize our code MiraCube2018, which will give you 20% off our Mirantis training, and we have Docker and Kubernetes courses available. So any questions for the presentation?
Please explain how the end user will be helping.
How the end users will be helping our infrastructure. So let's say I'm a video provider like YouTube. Okay, and right now I'm serving most of the data in North America, and it's out of Amazon Web Services. And tomorrow I get a spike in China for a certain kind of video, and my data is currently on Amazon and Google, but it's not available in China. How do I serve that user? Well, we know from learning that Google has invested a lot of money into their infrastructure. For example, they have their underwater cables. And through trial and error, we can learn that the latency of that is much lower, and we can better serve our users through that infrastructure. Perhaps it's cheaper as well. And make that decision and deploy on that infrastructure automatically by that user request. Does that make sense?
Isn't that what AWS does with CloudFront?
Sorry?
Isn't that what AWS does with CloudFront?
CloudFront.
CloudFront.
Can you explain?
That's a CDN of AWS.
That's the CDN, right?
Can you repeat the question on the mic so that you guys are got it?
Okay. So he's asking, doesn't AWS CDN where it does that? If it does, then it's great. But I think more of us can leverage that kind of knowledge and intelligence for ourselves across different kinds of clouds, not relying on the cloud providers to do that for us.
Assuming you have a loop like this, you know the customer not happy and experience some problem, latency, whatever, how would machine learning can suggest action, or like closed loop actions, triggering things? What would be?
What? So you're asking what will be the algorithms to make that happen?
Or what kind of real action you can take to make it happen?
I think if I knew the answer to that, I would probably not work for Mirantis and have my own company. Okay, I think that's all. So thank you so much for listening. And if you have any questions, please shoot me an email at ailey@mirantis.com.
Hey guys, this is the wall again. Hey, wake up. So, we do this every time as in the community spirit. How many of you are here and you're looking for opportunities right now? Please raise your hands.
Mic's off.
Mic's off?
Yes.
Okay, how many of you are here and are looking for opportunities right now? Please raise your hands. If you're shy, that's okay. How many of you are here to hire?
Anybody hiring?
Feeling, you need to raise your
I'm
hand right now.
hiring. Google's hiring.
There you go. And so, if you're looking for opportunity, keep your hands raised if you're hiring. Just look around. If you're looking for opportunity, these are the people you need to go, you can go and talk to and introduce yourself in the breaks. All right? And now we're going to break for 5 minutes so that you can use the restrooms.
And thanks to Andrew for his talk one more time.
Still not on? It's not working. Something wrong with it, right? I hope I
But I guess the hard part is I can't. We have 5 minutes.
Yeah, you can use that. Can the next speaker please come here?
So they have
Guys, we're gonna start right now. Everyone at the back, we're gonna start right now. You don't want to miss the awesome content. Come back to the chairs. Woo! Stop the food line there. No more beers. All right. I'll just invite the next speaker on the stage, and I'll give him the mic, and he's going to introduce himself and what he's going to talk about today. The talk is starting.
Thank you.
Hey everyone. Good evening. My name is Amiram, and I'm going to talk tonight about implementing autoscaler for Kubernetes. It's going to be pretty technical, so if you guys are sleepy, that's the time to wake up. So let's start with the most nicest slide I have here. So does somebody know what it is? Come on. Almost.
West Bank.
Almost. Come on, Gaza Strip, all right? So that's almost. That's Iron Dome. Anyone heard about Iron Dome?
Yes.
Great. So I was officer for 7 years in the Israeli military, and I was responsible for that system called Iron Dome. Iron Dome is basically a platform. It's a distributed platform for protecting the Israeli sky territory, so we can terminate and destroy missiles while they're in the air, trying to hit civilians, or even in the beyond the atmosphere. So that was a heck of experience. So we're going to talk tonight about how to implement Kubernetes autoscaler, and that slide shows you how come that we're basically even got into that place in the company that we're actually building an autoscaler for Kubernetes and what it is. So as of today, we manage over 100,000 EC2 instances at any single moment. That means that we saw like over probably a couple of thousands of Kubernetes environments for our customers. And we saw like even the largest Kubernetes environment running outside of Google. It's one of our customers. And we saw a lot of pains. This is why we basically started to build an autoscaler that is responsible for scaling nodes of Kubernetes very efficiently. So open your ears for this talk, because it's not only about Kubernetes, it's for like containers in general. This is implemented for Kubernetes. Awesome. So let's get started. So we'll talk about this. I'm going to talk about the term that we call tetriscaling or heterogeneous scaling when we talk with containers and instances or virtual machines in the cloud. And then we talk about how people are usually scaling Kubernetes. We call it the old school way, and what are the problems with old school way of scaling Kubernetes. And we'll talk about the concept of the autoscaler, how it works, and what is actually driving the autoscaler technology. So the basic anatomy of Kubernetes, for those of you who are unfamiliar, so we have nodes, Kubernetes nodes, and in each node we have pods running. Pods will usually contain containers, one or more. Pod is like is a logical unit of will deploy together, will have the same orchestration, the same networking. And then on top of that, we'll probably have a ingress controller. This is like where we connect our load balancing system with it, either if it's Nginx or Amazon ELB and so on. And then underneath all of that, we have the Kubernetes scheduler that usually connects to the master that's responsible. Hey, we have new container or new pod, or should we schedule that on the first node, and the second node, and the 10th node? That's what Kubernetes does. Now let's talk about what is the two layers heterogeneous scaling that we're talking about. So usually we have infrastructure, right? We buy VMs either from Amazon or any other cloud providers, and we have different type of instances. And then on top of these instances, on top of this fleet of instances, we'll deploy our cluster, distributed cluster. In that case, it will be Kubernetes. And then on top of that, we'll have a decoupled layer, another layer that will be the containers layer, the pods layer, right? We'll have pods in different sizes, right? You see small pod, large pod that requires more memory, or pod that requires less memory and more CPUs. So we have completely two different layers, right? So this is where the Tetris came from. Like, you need to make sure that the pod sizes will meet, because otherwise it won't work. Let's see some examples. And then when we scale, we have two layers of scaling. Right? When you say to scale a Kubernetes cluster, so let's say I have 10 nodes cluster, and then I want to run 1,000 pods. It cannot happen. I don't have enough room for 1,000 pods. I need to scale my infrastructure first. So how does these two layers of scaling work in a very, let's say, complex environment? So traditionally, how we scale like Kubernetes or any other distributed cluster, we usually aggregate our CPU and memory resources in the cluster, and then we say we put thresholds. So for example, you see here on CPU reservation and memory utilization, we say, yeah, if CPU utilization and the entire cluster is over 50%, I'd like to increase more nodes. And then if I have memory over like 80%, I'd like to increase more nodes. That will make sure that I'll have enough nodes to support my containers. But let's see the problems with that type of scaling. And by the way, if you guys have any questions or something is not clear, feel free to raise your hand and I'll take questions during. So again, going back to the Tetris scaling, all right, let's see what happens when you try to scale the wrong pod size, all right? So you see, every time you're gonna see these small square, we're gonna talk about 1 vCPU and half a gig of RAM. So you see we have different flavors of pods. And then here in the cluster, we have three CPUs, free, and 1.5 gig of RAM. That means that if you look back to the previous slide, so that means that we have about 1.5 gig of RAM free and 3 vCPUs, right? If a pod, which requires 3 CPUs and more than one, and 1 gig of RAM, right? You see we have C3 large, you can contain 3 pods, and we have M3 medium, we can contain 1. And we have the C3 2XL, we have room for only 1. We do have, in the aggregated way, we do have enough room to scale that pod, but in reality, in physics, we won't be able to squeeze that, right? So how do we avoid that? Second scenario is the wrong instance type. So here we have M3 medium, C3 2XL, and then we have this pod coming in, and then we scale the infrastructure, right? Because we don't have enough resources for that. The M3 medium is full. And then the C3 2XL is having only 2 available slots, but we need 3. Another M3 medium comes up. We don't need it, right? We won't be able to scale. And another problem that it might introduce is how do we do scale down, right? The whole part of Kubernetes is to have like really dynamic way. Whenever I need resources, is to get those resources. Whenever I need to scale down, is to scale them down. So let's see be in trouble. All right, the cluster right now is underutilized, right? Because I have only 1 container actually running on the M3 medium, and only 1 container running on the C3 2XL. So the cluster in total is not utilized more than 50%. And then I have my rule, if the cluster is utilized less than 60%, let's remove 1 node. But we remove the wrong node. So right now, we have this pod. This pod won't be able to be rescheduled, right? We don't have any free space on this M3 medium, not neither on this M3 medium. So we're in trouble.
Question?
Yeah.
What's the purpose of down? You still got the computer, it's on, unless you can turn it off. You don't really have any advantageous gains at all.
So the question was, what is the purpose of scaling down if you still have the computer, right? Unless you can turn it off.
Right.
So once you work in a cloud environment, like AWS or Google or Azure, you really want to scale down whenever you don't have to pay for the resources.
Yeah, I can understand that, but what if you're in private cloud?
In a private cloud, think about it that you have a fleet of servers, right? You can allocate these servers for different type of projects. So let's say that one project does not consume enough of your resources. Why not to allocate it to another project while it's not doing anything?
Or you may not have another project.
Not having, of course, so keep it available. But we're talking about like more elastic way where you really want to burst and scale down whenever you don't need it. Yeah.
Is this scenario where you are renting the VMs from the cloud provider and trying to deploy containers in it, as opposed to using the container service which is natively provided? In that case, all these problems do not exist.
So the question was, is that scenario where you're actually renting VMs and then deploying your own Kubernetes and deploying your own VM and your own containers on top of that, rather than to use like a managed or Kubernetes, an EKS, and so on? So the question is, if you're not using their own flavor, like also on GKE, and also on even Fargate, you bring the infrastructure, you bring the EC2, and you bring the VMs, and then they deploy that. They don't do the auto-scaling for you. So you define the rules.
Even in that case, the problem exists.
Even in that case, the problem exists. Yeah.
Thank you.
Awesome. You guys awake? It's getting more technical. So we said we have an orphan container, orphan pod that cannot be scheduled. Let's see. So pains that we've experienced with customers. So we said, let's build an incredible autoscaler. An incredible autoscaler that will first, no scaling policies, because every scaling policy that we try to use, not ideal in some circumstances. So we wanted to make it very easy. The second thing is to scale according to the cluster needs. So only when we catch events that the cluster is like, needs more resources, we'll give it to it, not whenever we think that the cluster needs resources. The third thing is, how do we scale fast? So we have a customer in the Bay Area, we won't mention his name, but they're like scaling in the morning hours from like 1,000 nodes, it can get to 10,000 nodes in like, just because their customers are waking up. They have some application of neighborhoods. You might know their name now. So they need to scale fast. So if you have like scaling policies, think about it. Every time that my cluster is 80% utilized, add more node. And then you're adding node, cluster rebalances, and then you're adding another nodes. And then every cycle, you're adding like fixed amount of nodes because this is how auto scaling works. As opposed to, hey, I need right now 9,000 servers. Give it to me. And not wait for like 3 hours to get these 9,000 nodes. Fourth point is how we do scale down very efficiently without having these orphan pods. And then we'll talk about headroom. Yeah, 1 second. And how we keep headroom for like incoming pods. What is headroom? We'll talk about it in a bit. Headroom is the ability to save some room in the cluster available for new pods to come in without having to spin up new instances. So that like we have like fast scaling in that headroom. Yeah.
So the question is, on scale down, is that where you can end an environment? It's like suspended from a cost perspective as well as without terminating.
So the question was, a scale down, is it like means to suspend the
scale down,
resource?
so you automate, so right, so you can automate that process where we do that when it's back
Right.
to come back. But in addition to that, like, do you still kind of that, you know, from a financial perspective, as you scale down, you still have to maintain that the environments, etc. Scale down and suspend a certain amount of resource scale down. How does that work?
Are you talking in the cloud environment or bare metal?
I'm talking to cloud.
Cloud?
Yeah.
So cloud is the question. So if I understood your question correctly, is you're asking like whenever I scale down, kind of like.
You still have those instances, right? I think.
So you still have those instances, but in fact you don't. You don't need them.
Okay.
Whenever you leave, just spin them up
That
again.
answers my question.
Yeah.
Can I ask a follow-up question?
Yeah.
You probably answered in the last slide. Then there's a question on start defrag. This defrag where you kind of go and figure out what's left. And you just drop them. However, the question I ask is, if I've got say 3 of these, you know, one vCPU by default, how do I make sure that 2 of them always is running even while I'm scaling down? So I'm assuming you have to drop them on the ground, but I still need the minimum.
So the question is that while the defragmentation works in scaling down nodes, the slide is how do I make sure that I have like a minimum amount of capacity that I don't like scale down from it, right?
By application specific.
By application specific. That called constraints, and we'll talk about it as well. Yeah.
A question. So, how do you have one cluster per use case, per project, per customer? How do you look at it? And when you say auto scaling, if they are multi-tenants in a single cluster, how do you scale based on you? Because you mentioned CPU and memory, the cluster base, right? Your projects is not using their resources. You realign that, or running out of space, do you spin off at that time? How do you look at all this?
I think I don't need to repeat the question, right? Everybody heard?
No, it's for the mic and the recording. That's why we need it. So it's getting recorded and streamed.
All right, it was a long question. Come on.
Sorry.
Everybody. All right. So when we do scale down, so how do we do it per project when we manage the auto scaling, or do we do it like per individual customer? Scale down.
The question is like, when do you decide to scale? Is it for the whole cluster?
All right.
Or multi-tenants in your cluster?
So how do we decide how to auto scale per the whole cluster, per like individual? So we don't host the clusters, so it's per customer, and then per customer, Kubernetes has a great feature called labeling. So then you can label specific like pods, and like you can say these labels like application A and this is application B, and then it will auto scale separately. So then you don't need to worry about it. And that's for your question as well. So you can set like constraints for labels, and then you make sure that for application A, I will always have this amount of capacity reserved for that.
If I read between lines of his question, his was one of the lines that you're talking about CPU and memory. What if you're scaling on I/O? So how do I now know whether the cluster's I/O or rather than CPU?
Question was, we talked about here about CPU and memory, but what happens if I scale based on I/O or scale based even on ports, available ports of the machine, right? So we'll talk about it as well. Awesome, guys, you're not sleeping. That's great. So how do we start with a real auto scaler? So the real auto scaler starts with catching the right events. There is a namespace within Kubernetes, in the system namespace of Kubernetes, that throws all the events. I'm missing memory. I'm missing ports. I'm missing CPU, and I'm missing I/O. Get my I/O that I need. You can define it on the Kubernetes level. And then the autoscaler itself is a pod, the system namespace of Kubernetes events. And with these events, we're able to go to the next step, which is the logic of how to scale up. So, yeah.
So, quick question on that. So, let's say you've got a resource constraint scaling, so like I/O, but your I/O is not local I/O, but remote I/O, say a cluster or something like that. You know, pod to pod, scale up, scale down, trying trade-offs.
So if I understood correctly, you're asking if you want to scale based on a custom metric.
So I/O is a good one.
I/O is a good one, right?
Yeah, so I've got I/O running on my web servers, and they're accessing resources hosted externally, getting the I/O off of that external hosting, which is also another pod, right? How do you deal with that type of trickle-down scaling requirements?
So I think that when you architect your different applications, so you know the dependencies. So you would want, for example, we were talking about the classic scenario where you have to do the front end and back end, right? And usually when you have your front end and back end, you will put them either on the same pod, so you want to scale together, because when we have more load on the front end, in some ratio, you would like to scale the back end as well. And if not, I believe that you can find a formula and define that formula to the auto scaler. But by the way, I know you from LinkedIn. You guys are putting a lot of ads. So,
Don't blame me. I don't manage the ads.
all right. So we said we're catching the events. All right. Once we catch the event, we go to the logic of scale up. So how do we do the scale up? We look at a pending pause. So for example, the master of Kubernetes said, all right, we need more pods to serve that specific application. And then we see what type of pods, right? Remember these different squares and different sizes. And then according to the size, we need to determine the right instance size because we have so many instance sizes. And to be honest, if you like use auto-scaling, native auto-scaling on AWS or native auto-scaling on Azure, so you choose like one machine type, let's say C3 to Excel, my favorite. And then you want to scale every time you have a load, get another one, get another one. But it doesn't get efficient enough at scale. So when you want to really scale, you don't want to, if you need like 3 vCPUs and 2.5 gig of RAM, you don't really need C3 Excel. Or when you really need a huge pod, you don't need one C3 Excel. You need like probably a couple or even a bigger one. So you need to determine the right instance type. So for example, see what happened here. We have 2 nodes, we have 4 pods in each, and then new pods are waiting on the queue, and then we scale up the 3rd node, and we schedule these 2 pods there. Yeah. Yeah. You can. The question was, can I pick and choose what instance types can be as part of it? Yeah, you can. You have like a list of instance type, of eligible instance type that you would like to scale from. You can label that on the pod level. Scale down, so how scale down works. From the formula that we saw, we're looking for nodes who are underutilized, like less than 40%, both on the memory and CPU. But then, after that you determine a node which is idle, you don't want to terminate that node before you really make sure that the tasks and the pods and the containers that are running on the specific server can be reallocated to different machines, just like we had in the previous slide. So the cluster does that, but also make sure that even ports are available. So for example, there are many constraints when you schedule like a container that listens on port 80. And the port is mapped to port 80, and you don't want, and so for example, we have another space for that container on different hosts, but in fact, we won't be able to start a container because port 80 is already in use. So the autoscaler takes that into consideration as well. Then we drain the instance. Question? Thank you, sir. Draining the instance, waiting for the tasks to be rescheduled, and then terminating the instance. Yeah.
Oh, my question is, what if the task running on the inefficient instance is not interruptible? How do you decide whether or not it's
Good question. So the question was, what if a task that's running on a specific instance, which is appears to be idle, is not interruptible? I cannot take that because it's having some state or it's a database or whatever. So on the, usually when you have tasks like this, you will label these tasks as stateful. And then you will make sure that these will be labeled on hosts that are not going to be scaled down. Coming to your question.
In that case, we will be able to try to schedule all those tasks on the same instance. Otherwise, you scale up and down, you can get into a very flat environment. You have a bunch of tasks, a bunch of instances running, a bunch of underutilized applications, and you cannot move on.
Awesome point. The point was, once we have this bunch of tasks that cannot be rescheduled because they're stateful, will the autoscaler make sure to schedule them and aggregate them on the same host so we don't spread them on too many hosts and then we get like even a worse defragmentation? So yes. Yeah. So the question is, if that autoscaler supports AZ awareness,
yes.
AZ stickiness. So yes, it's one of the configurations. So great questions, guys. Keep it coming. Awesome. So that about the scale down. Any more questions? All right. So this is how defragmentation works. We discussed about it. Headroom. Anybody heard about that term? Awesome. So what is a headroom? A headroom is the ability to have in my cluster some available resources that are not in use, but I'd like them to be in use probably in the near future. So I won't be needing to scale from like scratch machines because it takes more time. Headroom is we define a unit. A unit is a combination of CPU and RAM, and then you define how many units you want. So for example, my most frequent pod requires 8 vCPUs and 10 gig of RAM and units of it. So then the autoscaler will make sure that I have enough units in the cluster available. So let's see this example in live. So we define a unit of CPU shares and half a gig of RAM. And then you see all these gray squares. These are like the available space. So you see on the M3 medium, we have 1 unit available. On the C3 to XL, we have 2 units available. And then on this M3 medium, we have 1. And the headroom says we need 5 units, and here we have 4. So what will happen automatically behind the scenes, the autoscaler will launch a new M3 medium that will contain that needed headroom to meet that demand. This is the nirvana of Kubernetes clusters, fully utilized clusters. You can see this is from a real production environment. You can see nodes being utilized for over like 90%. This node was like just scaling up, this one here. And you see the different type of pods being scheduled on the different machines. And you see the utilization of each node. By the way, we reserve about 10% of each node for the cluster management because you cannot really put like 100% of the like containers for the 100% of the nodes. And unfortunately, that's going to be one slide before the last slide. So let's take questions. Yeah, that's our monitoring. That's our monitoring that shows you on the pod on the instance level how many pods are being scheduled and how much of this node is actually being consumed. Like over time. Yeah. Yes, sir.
From your experience, do you think you can apply machine learning to anticipate the patterns in the data center that you work with?
So the question is, can we apply machine learning to that auto-scaling and then learn patterns and then scale automatically based on these patterns? So yes, we're working on it these days with some very interesting customer case studies. It's still not there yet. It's scaling based on like headroom and available resources and the cluster events, but we're definitely going that direction. Yes.
So is this autoscaler upstream, and how can we access and use it?
So the question is how you can actually start using this autoscaler. So this autoscaler is just a pod that is being scheduled on your Kubernetes environment. This pod has to talk to our SaaS. We have like a platform that talks to the platform. Just the SaaS takes all the configuration from the pod, makes the the logic of how to scale and which instance to scale, and then sends a command to the pod to basically launch nodes within the cluster. So we have a great blog post that explains how to get started with this autoscaler on standard.
Yes, 2 questions. So one which might actually answer the LinkedIn question list. So if you're doing something like remote IO, I'm assuming that there's a way to do a remote question mark. So that was really a, if I have a cluster A that is dependent on, if I have a cluster A that's dependent on IO that's on, say, pod A that's dependent on pod B, how can pod B call pod A to say, okay, I think that you're idle, but are you really idle? Okay, that's one question. And then the other one, actually, to answer that one. Well, the second question is, you're really doing a la carte effective instance sizing here. And I anticipate that the actual cloud providers will start doing this too. So instead of having a CPU to XL, they'll say, well, you can have 3 vCPUs, 256 GB of RAM of 500 CPUs and 5 gig of RAM. So do you see that affecting you in the future, or do you see it complementary?
Yeah, so regarding the first question, I think that what happens is that there is one pod on the namespace level that can see everything that happens on the different instances and pods, all right? It takes that from the master configuration because there is a Kubernetes process running on each node and reporting to the master. And then we take all the information from there and then knowing what happened with pod A or pod B or pod C, whatever instance it is. So then this is how we make sure that, are you idle? Yeah, I know that you're idle because your hypervisor told me that you're idle because the master knows that. So that's first. And to the second question is about cloud providers doing it. So eventually, you know, Amazon will do everything, right? They will kill us all. Right? But in the meantime, I think they have bigger troubles. So they're trying to do bigger things. And in the end of the day, this is like immediate value to customers. And we're always like looking at customers and not on what cloud providers will do. Probably the customers will pay us money at the end of the month and not the cloud providers. So we're concentrating on them. So I saw questions there. Yeah.
Do you also use Istio in your clusters?
The question is if you're using Istio in our cluster. So no, we're not using it at the moment Istio. But happy to discuss later. More question, folks? Yeah.
Auto-scale networking.
How do we auto-scale networking?
Scale 1,000 containers. The network. In terms of IP addresses first, and latency, on the bandwidth, everything is supposed to be as well. And when you scale down, it's more complex because you have network goes along with policy. When you scale it, you need to scale with policy as well. But scale down is more complex.
So when you're talking about scaling network,
you add more subnet. You add more capacity for containers. For the containers.
Right.
One container is not too much, but 1,000 containers is a completely different story.
I think that's not a Kubernetes problem. That's your network infrastructure problem. So if your network can support that, it's another layer of I think.
Because the SDN, right now Kubernetes offers the CNI plugins where each vendor come in and do their own network. No one really do it auto scale the way it's supposed to be done. But when you do that, you need to go for it with the network. You cannot scale without network.
I can tell you my experience with VMs. All right, so it's either you have VM with enough, bandwidth that you can play with, or then you don't. And if you have a VM like a large VM with like large bandwidth, so you can put as many workloads as you want on that VM as long as it had the bandwidth to support that, right? Usually, there is one of the patterns that we saw a lot on regular web application clusters is that people are actually measuring, and I was really surprised to see that because when I came out from the army, I was like really old school, scaling only CPU. CPU is the only thing we really care about. And then I saw many people scaling based on network out. So they're actually measuring how much bytes are going out of their pipe, of their NIC. And if there's like more bytes going out of the NIC, you just scale more instances because that means you have more traffic. Then the more instances you add, that means exponentially or linearly, you have more bandwidth, right? So once you add more capacity, you just have more network bandwidth. I don't think that if you add more capacity, you're like killing your network bandwidth.
So why is it a single tenant? Here you look at Kubernetes, even the one big tenancy. Every tenant has a limited resources. How do you have a maintenance and you still not using and bring it to you?
That's a great point. That's a great point about like when in a multi-tenant environment, because containers by definition is a multi-tenant environment. What happens if one container is consuming more network than the other, and then it's just making the host to look bad? Still don't have it in the autoscaler. We still haven't encountered this, to be honest. But that's a great point. That's a great point.
So
To respond to your question, one of the common ways this is done right now is to identify the high network bandwidth applications in your environment. You start applying affinity or anti-affinity rules on those deployments. So if you have, say, Spark for some big data processing stuff, you declare anti-affinity such that your Spark jobs cannot be scheduled on the same instances as your Spark jobs.
But yeah, but it will also, I think it would be nice to have like a view of that so you know which container is consuming most of the network so you can also schedule it on specific VMs. Yeah.
I was actually going to make a similar point. So KVM under the hood actually has some parameters where you can do QoS actually at the instance level and min, max, burst capacity on a couple of different variables. So depending on how your overall environment needs to be orchestrated, you have some knobs under the container to kind of sandbox a container from going off into the weeds.
Interesting. Yeah.
Just when I question networking, I can think of security also, right? Do you have a way to know that to enable that container only when the network has been re-provisioned, the security policies are in place, and then you can turn on your container. Do you have a way to synchronize that?
That's none of the autoscaler issues. That's the Kubernetes that's responsible for that. Because when you launch a VM, kubectl will start and the kube AVM and all the nodes will start on it. Only when it's like available and ready to use, then the master will actually schedule the containers. That's the autoscaler just needs to bring the node. Yeah.
You have a way of managing conflicts in between events. So let's say you have idle machine at T0. So you say, okay, I'm going to bring it down. And at T+1, you actually have a spike of network. So as you're bringing down your machine, actually there's like a peak of network or of traffic. And you have actually a conflict of events of like, oh, should I scale down or should I scale up? You have a way of managing that?
That's a great question. We've encountered that a lot when we developed the autoscaler. So the question was like, it's called like, chasing your own tail. So you scale down a machine, and then another machine gets choked, and then you need to scale up, and then this machine is idle, and then you need to scale down, and then this machine again gets choked. So yeah, we track that, and we would never, like if we see that situation, we'll probably hold. We have between each scaling activity, we have something that calls cool down period of time, so that we don't like whenever we scale up, we wait for a certain amount to make sure the cluster is stabilized. And then whenever we scale down, we see, hey, what's going on with the cluster? Should we scale up back, or should we continue to hold? So we saw it a lot at the beginning, but in fact, it doesn't happen a lot quite often. Yeah.
Do you apply this to on-prem?
It can work on-prem to give you visibility and to do the scaling, but the problem with on-prem that we don't have actual like tangible API to launch a server because it's on-prem. For bare metal. But you can use that for like so on, but it will not do the actual part of scaling. Yeah.
The opposite of this question. I just wonder if you can utilize spot instances, for example, realize, okay, this instance is going to be down in 2 minutes, so we better not scale there.
So this is how we're making money. I was trying hard not to talk marketing, but yeah, we're doing all of this on spot instances. And that's the secret sauce. Our platform is basically, we have a machine learning in the background that looks continuously at the spot market prices as it changes for the most highly available, highly economical spot instances, so we can fit into these clusters. And then whenever we need to scale down or up, we'll do it from the spot instances. Environment of like 4,000 nodes on the spot.
So that's really good.
Awesome, folks. I think it was refreshing, and I hope you enjoyed that. For those of you who are using Kops, just 2 lines that you need to add, and then you can get a supervision. And I hope you guys have fun, and see you in the next meetups.
Thank you so much.
You're welcome.
Yes, thank you to everybody. Check out the next meetup that will be posted, I'd say, within the next week and a half. We have a placeholder up right now, but we are finalizing the content. Right now, we have enough content that's going to take us out until about May. But if you are looking to talk, there is a form on the meetup site. Just go ahead and fill that out. Oh, and if you also work for an employer that can host up to, like, say, 150 people, we are taking requests for that as well, and the form covers that too. Right, and that's it. Thanks so much. Oh, if you're a Googler, take your bike home, please. Thank you. This is JFrog space, not Google. Thanks.
And I think the speakers are going to be here. If you have any questions, you can ask them.
Yep.
Yeah.